This is review A, numbers 1 through 10. On number 1, it says if y is equal to x cosine x, then dy dx is equal to, you have to use the product rule here because we have two factors. The first factor is x and the second factor is cosine x. So dy dx will be equal to the first, which is x, times the derivative of the second, which would be negative sine x, plus the second, which is cosine x, times the derivative of the first. The derivative of x is just 1. Okay, so the only thing we can really do here is rewrite this. Well, x times negative sine x is negative x sine x, and then we have plus cosine x. So I'm going to put the positive value first, and then the negative value second. And that's answer choice C. On number 2, it says let f be the function given by f of x, on which of the following intervals is the function increasing. Okay, so if I have the original function and I want to find where it's increasing, I need to look at the slope of the original function. And wherever the slope is positive, that function is increasing. So to find the slope, we'll differentiate f. So f prime will equal 600 minus 3x squared. Now we're going to start with the critical values by setting this equal to 0. So let's add 3x squared to both sides so that we have 600 is equal to 3x squared. Now divide by 3. 600 divided by 3 is 200. Now take the square root to get rid of that x squared. So we have x is equal to plus or minus the square root of 200. Now when I look at the answer choices, I notice that none of those are there, but I can simplify root 200. Let's change that to plus or minus 100 times 2. So what you do is you take the largest factor of 200 that's also a perfect square, and you separate 200 into factors. Now the square root of 100 is 10, so I have plus or minus 10 root 2. And those are my critical values. So I always need to set up my table. Negative 10 root 2 is the smallest, 10 root 2 is the largest critical value. And you plug numbers less than, between, and greater than those critical numbers into the derivative of f. Okay, so let's say I chose something like negative 100, 0, and 100. If I take negative 100 and I plug it into f prime, which is here, I'm going to have 600 minus a positive value that's really large, right? Negative 100 squared is the same thing as positive 100 squared times 3. That's going to be a lot larger than 600, so I'm going to have a negative. If I plug in 0, I have 600 minus 0, and that's a positive. If I plug in 100, I have 600 minus a really large number, which again is negative. So the function is decreasing up until negative 10 root 2, increasing between negative 10 root 2 and 10 root 2, and decreasing after 10 root 2. So that means that our answer is A. Okay, let's look at number 3. Number 3 says the integral of secant squared x dx. This is just a rule that you have to have memorized. The antiderivative of secant squared x is tangent x. And always put plus c since this is not a definite integral. Okay, number 4, if f of x is equal to 4x minus 2 plus 3 ln x, then f prime is equal to, f prime of 1, excuse me, is equal to. First we have to find f prime of x, which would be 4x, the derivative of 4x is 4, the derivative of 2 is 0, the derivative of 3 ln x is 3 times 1 over x, or 3 over x. Now it says to find f prime of 1, so we plug in 1 for x, and we have 4 plus 3 over 1, which is 7. Okay, let's look at number 5. On number 5, it says the graph of the function f is shown below. Which of the following statements is false? Okay, so this is the graph of f, the original function. Which one is false? The limit as x approaches 2 of f of x exists. Remember, for the limit to exist, the y value has to approach the same number from the left and the right of the x value shown. So at 2, the y value from the left is approaching 6, and from the right. Remember, we don't really care what's happening at 2, we care what's happening around 2. So that is a true statement. As x approaches 3, the limit exists. Here's 3, the y value is approaching 3 from the left and 3 from the right, so it exists. The limit as x approaches 5 exists. Well, the y value is approaching 2 from the left and 2 from the right. That's true. The limit as x approaches 4 exists. From the right, the y value is approaching 5. I'm sorry, from the left, the y value is approaching 5. From the right, the y value is approaching 4. Those are different numbers, and therefore the limit does not exist. Let's double check the last one. The function f is continuous at x equals 3. Well, you've got a filled in circle, no jumps or discontinuities, so that is true. So D is our answer. Okay, let's look at number 6. It says a particle moves along the x-axis. The velocity of the particle at time t is 3t minus t squared. What is the total distance traveled from 0 to 2? So when you see total distance, what you're going to want to do is take the antiderivative of the absolute value of the velocity. Remember that total distance, you have to take into account that velocity can sometimes be negative because of a backward direction, or in this case, leftward direction. So you want to do the absolute value to find total distance. If it asks for displacement, that's different. You wouldn't want to use the absolute value symbols. So just be careful, read carefully, and go from there. Okay, so we have the integral from 0 to 2 of 3t minus t squared dt. The antiderivative of 3t is 3t squared over 2 minus t cubed over 3 from 0 to 2. When I plug in 2 here, I've got 2 squared, which is 4, times 3 is 12, divided by 2 is 6, minus 2 cubed is 8, divided by 3, minus, and here we plug in 0 to either factor, or either term rather, and you get 0. So we've got to find a common denominator. So this is 18 minus 8 over 3, which is 10 over 3. So answer choice A. 7. On number 7, it says if y is equal to x squared minus sine x to the 4th, then y prime is equal to. This is a chain rule, so we'll bring the 4 down. And then we'll multiply by the derivative of the inside. So again, you take the derivative of the outside, so 4 and then u cubed, and you leave the inside exactly as it is. Then multiply by the derivative of the inside. So x squared gives us 2x. The derivative of sine x is cosine x. And we're done. So we've got 4, x squared minus sine x cubed, 2x minus cosine x, that's D. Okay, let's look at number 8. A tank contains 40 liters of oil at time t equals 3 hours. We're going to find a left Riemann sum with 3 subintervals to approximate the number of liters of oil in the tank at t equals 14 hours. So what we're going to need to do here is begin with 40, the original amount, and add that to 3 areas of 3 rectangles. Okay, so we're going to use the leftmost y value since we're finding a left Riemann sum. And then the width of the rectangles will be the difference between each x. Okay, so 6 minus 3 is 3, 11 minus 6 gives me 5, 14 minus 11 gives me 3. So I'll have 40 plus, the area of our first rectangle will be 3 times 6.1 plus 5 times 5.8 plus 3 times 5.5. Okay, here I guess I should be uniform. Let's do that. Okay, and you can use your margin to multiply these out and add these up, but you should end up with 103.8. Okay, if we were using right Riemann sums, we wouldn't have used 6.1, we would have used these 3 values. So it just depends on what you're asked to do. Okay, let's look at number 9. It says let f be the function defined above for what value of k is f continuous at x equals 1. So what you see here is that x minus 1 cancels out in the first piece. If you have a factor that cancels out, you can set that factor equal to 0, and that shows you where the hole in the graph is. So there's a hole at x equals 1. Now k is going to fill in that hole. When x is 1, whatever k is, that's going to fill in the hole. So what I want to do is plug in 1 for x into what's remaining, which is 3x plus 2, and that's going to give me my k value. So 3 plus 2 equals 5. Okay, so if k were 5, it would plug in that hole at 1. What is the area of the region in the first quadrant bounded by the graph of y equals e to the x over 3 and the line x equals 3? Okay, so to find that area in the first quadrant, remember that x equals 3 is a vertical line at 3. So the first quadrant, we're going to use the boundaries 0 to 3. Okay, I don't care about anything less than 0 because that's not in the first quadrant any longer. Okay, so the integral from 0 to 3 of our function will give us the area. So since we have something other than just x in the exponent, let's use substitution. That means that du is going to be 1/3 dx. So 3 du will equal dx. Okay? Now we also need to find u of 3 and u of 0. Well, u of 3 is going to be 3 over 3, which is 1. U of 0 will be 0 over 3, which is 0. So my new integral is going to be the integral from 0 to 1 of e to the u du. The integral of e to the u is just e to the u. We know that from memorizing our rules. And don't forget the 3. That'll get you. Okay? So now we have 3 times e to the 1 minus e to the 0. And remember that e to the 0 is just equal to 1. That's one of your rules as well. So now we have 3e minus 3, because you have to distribute that 3. And that is answer choice B.